All right, let's talk about elastic load balancers. The number one function of load balancers is to distribute inbound connections to one or more back-end endpoints. And AWS has three different load balancers that we can use. First being an application load balancer, the next being a network load balancer, and it also has a classic load balancer. And it kind of discourages you from using the classic load balancer, but they keep it out there because there are certain customers who still want to use it. And the difference between these load balancers is the application load balancer generally works on layer 7. And if you recall from our OSI model lesson, layer 7 is the application layer, hence why it's called an application load balancer. And it generally deals with HTTP and HTTPS, while the network load balancer operates on layer 4, which is the TCP level. Now, we can use load balancers either facing the internet in a public way, or we can use them internally inside our VPCs to distribute internal workloads. And also, load balancers are auto-scaling, hence the elastic part. And as they scale, they're going to consume IP addresses within your VPC subnet. So you should make sure that you have plenty of spare addresses, especially remembering there are certain reserved addresses that you're just not going to be able to use. And if you run out of addresses inside a VPC subnet, then you could run into problems with scaling. Now, the different types of load balancers have some similarities, but they also have some differences. And on the exam, you're going to need to know a little bit about some of those similarities and differences. So first, let's look at the similarities. So all the load balancers have zonal failover, meaning that if an AZ goes down, they're going to fail over to another functioning AZ. Now, application and network load balancers can only work inside a VPC, whereas back in the olden days when there was really no concept of a VPC, that was called EC2 Classic. The classic load balancer can still work in EC2 Classic, but as I said before, AWS really discourages this. And if you're building any sort of forward-looking architecture, be sure you're using VPCs, and therefore you really would have no need to use Classic. You can either use an ALB or an NLB. Now, all the load balancers have health checks, and they can balance loads across zone. They also have plenty of CloudWatch metrics, and they can also now terminate SSL connections. Previously, only application load balancer could terminate those connections, but now the NLB has TLS support, so it can now do those terminations as well. And all the load balancers have resource-based IAM permissions, so you can define certain IAM permissions for users and roles and resources that can access or do stuff to those load balancers. Now here's a comparison chart of the differences. It's not a full exhaustive list of all the features, but I just pulled out some where there are definitely differences between the different load balancers. And I'll call your attention to a few of these items that seem to appear commonly on the exam. And note the protocols here. The application load balancer works at layer 7, that's HTTP and HTTPS, while the network load balancer works at a lower level, layer 4, and it makes use of TCP, UDP, and TLS. Now, only the application load balancer supports SNI, which we cover in a separate lecture on the Amazon Certificate Manager. And only network load balancers support the assignment of a static IP. Whereas with an ALB, you need to use the fully qualified domain name as its endpoint. Now, of course, you can alias that using Route 53 if you want to. Now, as far as routing options, and this means how you can control the flow of traffic to your backend servers. At level 4, where the network load balancers are, we don't have much available. Basically, we can route based on the source port. So we can route traffic to instance 1 if that request comes in on port 81, or instance 2 if the request comes in on port 82. But for TCP, because that's a connection-oriented protocol, once a routing from a client has been made to a backend host, that routing is persisted for the duration of the connection. Now, ALBs, on the other hand, have lots of options for routing. We can route based on the domain host name given or the path given in the URL. We'll see an example of this in a bit. And we can route based on HTTP header elements, HTTP method options like post, put, and get. And we can even route based on the source IP and a query string parameter inside the URL. Lots of flexibility here. Application load balancers work at a higher level. It works at the application layer. So it can do some pretty interesting things. Like one of the features is path-based routing. So based on the URL path included by the client, we can direct that load to one of many different target groups. So in this case, if we have login.acme.com/customer, we can direct that to a set of servers for the customer web fleet target group. Now, network load balancers, on the other hand, they really excel at speed. If you just need raw speed and throughput, then you probably want to use a network load balancer. And you can use a network load balancer to direct HTTP and HTTPS traffic. So in this scenario, let's say we have a client that uses SCP to copy files or upload files. And so we're using the network load balancer to distribute the work across a target group of worker instances. They will take that file, maybe they run some processing on it to extract some metadata. And in this case, let's just say they're updating DynamoDB. Now, sticky sessions are an important feature for web applications. Most web applications keep up with clients using session IDs. And this is a way to uniquely identify the client for stuff like shopping carts and session parameters. If I just direct the client to whatever web server has less load, then I take a chance of landing that client on a web server that doesn't have the session variables that maybe a previous connection used. So enabling sticky sessions is how the ELB can keep track of the client and which web server it handed it off to, so it can keep sending it back to that same web server, thus allowing continuity for the client and the web server.